it will try to tell you a very good story. Okay, so let's try to select what is central tendency first. So central tendency is nothing but it is a way in which the group of data clusters around a central value. This is what we call it as a central tendency. But the question is, why do we need this? Nice. Why do I need central tendency value? What are the
To
advantages that I'm going
compare.
to get? Excellent. One of the major advantages of central tendency values for comparison, isn't it, guys? So let me tell you. So there are two schools, school A and school B. Now you wanted to check like which particular school is faring good in the IQ levels, right, of 10th grade students. The moment you put some test, right, the more you will get some values. Because as an example, school A has 50 students in the 10th class, and you conducted some exam, and the average came to be 95. The school B, right, the same test has been conducted for the 10th grade students, right? There are again 50 students, right? When you took in a central tendency value, it came to be 65. Now will you be able to compare the results, guys? Same grade, same number of students, but different schools.
Yes.
Yes, right? So the reason the central tendency values are one of those very good measures which will help you for comparisons. Okay, but what else? Is it only for comparisons? Think through. It has nothing to do with respect to data science skills or statistical skills. If I'm getting a central value or central tendency value, how it is going to help me? One is for comparisons. What else? No, like keep on sharing your thoughts, right? As I said, it is all about sharing your thoughts. Don't worry about the accuracy or correctness of your answers. No one?
The most frequent occurring thing, for example, if a car race has been won on a specific type of car, with central tendency we can identify what is the most frequent used car type.
Okay, so in other words, let me rephrase a little. It is nothing but a representative value, isn't it, guys? Say as an example, in my school A, there are 50 students. Now, in this particular value of 95, the central tendency value of 95, is it not representing the entire 50 students? Yes or no?
Yes.
Right? So instead of having the 50 different values, some people might got 100, 98, 97, 93, 92, or whatever could be the values. But ultimately, I'm just trying to act, or I'm trying to just depend upon this final central tendency value as a representative value, isn't it? So there is the first and foremost usage of your central tendency value is it will act as a representation of the entire bunch of data elements that you're working on, right? And the second advantage, as our dear friend has said, it is all about for comparisons, right? So when you're trying to find one single value as a representation of the entire data values, are we going to condense the data or not? Is the data getting condensed in the representation form?
Yes.
Right? So definitely I don't require those 50 data points for the further analysis, right? I'm just depending upon this particular final value. So the reason there is data condensing is happening as part of the process, right? And finally, even though we talk about central tendency values as a descriptive statistical measures, but these same techniques is going to be helpful in further statistical analysis, right? The same values would be useful, some of those advanced and latest statistical analysis too. So don't think these are learning just a fundamental things, but these fundamental topics are empowering some of the advanced or further statistical analysis. So this is the reason why people prefer central tendency values. And the moment you look at them as a mere number, it will not tell you a story, because data scientist has to be a very good storyteller, because what you see is always numbers, but if you just project those numbers in front of the business teams and the business leaders, right, it will not tell you any story. So you have to tell a story based upon the problem statement, based upon the domain you're working on. Okay, guys, make sense? Very good. What is central tendency and why do you need a central tendency?
Yeah.
Excellent. Now let's try to talk about those three sub numerical measures that are available within central tendency. The first one is called as a mean. Right, guys? I think we don't require any introduction. Guys, what do you mean by mean? How do you calculate the mean?
Sum of all the values divided by the count.
Simple. The sum of all values divided by the count of the values will give you the mean. So, but we are trying to talk about mean, right? So actually the mean is a word that should be used for population or sample.
Population.
As per yesterday session, what we have learned
For
Population.
population.
for population. But what do I call the central tendency value if I'm doing for sample?
Average.
Average. So, but when it comes to central tendency value of mean and averages, do you think the formula would change? Yes, will change?
No.
No, right? So sum of all values divided by the count is the same whether you are trying to work on your sample of the data or else when you are working on the population of the data. Okay, but few of the numerical measures, the formula would change on the denominator side, but since you are living in a central tendency value, only that representation values, right, is going to change. So as you see here, in case of your average, it is been denoted as X bar. So there is an hat or there is a bar on top of the X that we are going to write. So this is a symbolic notation if you wanted to call it as an average. But the moment you try to talk about a mean, it is being represented by the Greek letter called mu. Guys, able to see this? The formula is not changing. Have you seen this? Sigma x by n. What do you mean by sigma? Sigma is nothing but summation of all the elements present in a particular frame. Okay, make sense? Are you clear about this? Any questions? Yes, are you clear?
Yes.
Okay, now guys, please be available. I'm just trying to write some numbers. I want you to calculate the mean of these numbers. If you are in front of an Excel sheet or calculators, I need a quick reply. 60, 72, 61, 66, 63, 66, 59, 64, 71, and 68. So how many total numbers do I have? 3, 6, 9, and 10. So the total of 10 numbers. Now if I calculate the mean of it, what would be the value, guys? Anyone? Okay, 65. Okay, now observe this. Why am I trying to talk about this high school mathematics now? Guys, observe this. I'm going to copy paste the same data points now. Okay, I'm just trying to change one number. Now, Juhi, I am not expecting you to tell the numerical value here, but what are your observations? The same data points, what happened? Instead of trying to put one number to be of 68, I just updated to be 680. What do you think would happen now? What are your observations? What do you think would happen to the mean value?
It will be a larger number.
It would be a larger number. Okay. So what is the takeaway here? Guys, what is the takeaway? What is your understanding? Why did I show this example and what is an inference that you're able to make it now?
A small change can impact uh, largely.
Do you think 68 to 680 is a small change?
I mean, the number 0. I mean, if it is an error.
Come on, Juhi. So this is not a small zero getting added, right? It is a 68. Say as an example, you're trying to calculate the age of a particular person. His age about 68. Now you made it a 680. You see, it's not a small change. It's a huge change.
Yeah.
Right?
Mhm.
Getting 10x times more. 10x. Not I'm talking about percentages. It is 10 times more than the original number. Guys, what is an inference? Why did I talk about this example and what I'm trying to say here?
You can say mean is directly proportional to the data elements.
Okay. Okay, almost there. Can someone rephrase those statements?
Representation of the data.
No. So we say that mean is sensitive towards your outliers. Guys, it's not an outlier. The rest of the data points are hovering around 59 to 72. Suddenly, one of the value of 68 has got updated to 680. Is it an extreme value, an anomaly in the data or not? Yes or no?
Yes.
Yes. The moment your data set has, the moment your column, the moment your variable has extreme values or anomalies or outliers, can you make use of the mean as a standard value? Is it going to help you? Is it going to give you the good representation of the data because of just one black sheep?
No.
No. So the reason we say mean is sensitive towards such kind of an extreme value behaviors. Make sense? Yes or no? Can I make this statement or no?
Yes.
Yes. And the second important point is, can you calculate mean on the nominal type of data, guys? Can we? No, right? So the reason the data has to be numerical, which is very fundamental. Now let's try to move on to the second one. Right, so the first one is mean and the second one is median. Okay, let's try to understand what is median then. Guys, any idea? Anyone able to remember and recollect your childhood or high school mathematics? What do you mean by median?
Middle value in a sorted list.
Very, very important point is the suffix. It has to be sorted first, right? The moment people talk about median, they just jump onto the definition of saying it is the middlemost value. It is not about middlemost value. It is a middle score for a set of data that has to be arranged in the order of magnitude. It has to be sorted first. Once the data is sorted, then you can take the middlemost value for a set of data. Okay. Now let's try to select. Let me take an example and try to show you how can you calculate the median value. And again, guys, pay attention. My objective is not to show you the formula of these simple examples. My objective was to help you to understand this important point. Okay. Most of the data scientists, right? So they jump onto the machine learning algorithm without understanding the basic differences of when to use what. Okay. And my students should not fall in that particular place. Let me take a simple data point here. Okay. I'm just trying to take some random data points, the total of 11 elements that I'm going to provide here. And can someone help me? What is the first step? I have to first sort the data, isn't it, guys? So what do you mean by sorting?
From ascending to descending.
Right, from ascending to descending or descending to ascending, but the one of the most common way of trying to arrange any data is by default it happens in the chronological order of ascending. Okay, so I'm just trying to arrange the data. So what is the minimum value?
14.
14. And what is the maximum value?
92.
92. So it means I need to arrange these 11 data elements in the sorting order starting with 14 all the way to 92. So since there are the total number of elements is 11, we call them as even number or odd number.
Odd.
It is an odd number. So there are total of 11 elements. Since this is an odd number, what is the beauty of it? I can just pick the middlemost positional value. Guys, what is the middlemost position value in 11?
6.
Right? The sixth positional value is generally called as middlemost value, and which is nothing but my 56. So 1, 2, 3, 4, 5, 6. So this is the middlemost number, which I can call it as median. Are you clear on this? Any questions?
Yeah.
How about others, guys? Is it only you in this session? No, right? How about others? Divya, Bindu?
Good. Yeah, it's clear.
So appreciate your responses, at least in the chat. I've been requesting this for all this while, but I don't see any replies in the chat. Guys, please do make a habit, either confirm over the voice or else confirm in the chat. It's up to you. Okay, now what I'm trying to do in this next example, on the same data set, what I've done, I just removed the 92 value. Okay, so what I will be left with? 10 or 11?
10.
There will be only 10 numbers. So I'm just trying to opt for the same ordering. Okay, right? If I have to sort the data, I can just make use of the same thing. Okay, without the value of 92. Okay, now if I have to talk about the median, now how many elements are there? There are only 10 elements, then it will become a even value. It means the middlemost positions would be 2, isn't it, guys? Yes or no?
Yes. Yes.
Right, but how do you deal with? Because I said if it is in the case of odd, there is only single positional value, so that I can just opt for that particular single value. But when you're dealing with the data which has even number of elements, then the middlemost position would be 2. Now how can I deal with this?
We can sum it up and divide it by 2.
Yeah, so what we do is we generally ask to take a simple average of those 2 positional values. It means my 55 plus 56 divided by 2 is nothing but a simple average of those 2 elements, which will help me to get the median value. Now the median value is 55.5 is my median value in this particular case. Okay guys, are we clear? How do we handle the median case in case of an odd number or in case of a even numbers?
Yes.
Clear?
Yes.
Excellent. Now let me put a little trick here. Okay. Example 3 on the same data set. On the same data set. I'm changing one number to something else. So there is a value called 89. I just update it to be 890. Now Bindu, what are your thoughts?
So if it is odd number, the median doesn't change.
Mm-hmm. You get to know, right? So I just copied the same data as part of the example 2 and I just updated one of the value to be of 890. Now what are your thoughts on the median value? What is your inference?
It doesn't change then.
Why? Because I updated the value, right? The data is no longer the same.
But we are taking the middle element, right? So yes.
Okay, very good. So you can say always this with confidence. Guys, are you able to observe this? When I'm working with respect to the mean, the moment my data has some extreme value behavior, immediately the mean is getting impacted. But when it comes to median, even if it has some extreme value behavior, is my median getting updated or impacted by this? Guys, is it going to change? The total number of are still even. They're the same number of elements. I just sorted them in the chronological order. Since it is an extreme value, you just move towards the right, extreme right. So what happened? My values are still remaining the same. So what is the takeaway here? What is the takeaway?
Mean is not sensitive to outlier.
Simple. Mean is not sensitive to what's your extreme values or outliers. So the reason people on your day-to-day jobs will prefer median if you suspect if your data has some extreme value behavior. So it means mean is not a good representation of your data if it has some extreme value behavior, and people prefer median over mean if data is either skewed or towards having some extreme value behavior. Are you clear about this, guys? This is very, very important, very fundamental, but very, very important. When do you choose what is should be very easy for all those data scientists. Clear? Any questions here? Okay, now the data has to be only numerical or only ordinal? Or it is, has to be numerical, ordinal, and nominal. What kind of a data that you can work on?
Only numerical.
Has to be numerical, and since ordinal data has also magnitude and sorting is available, right? If it is not throwing a very different ambiguous situations, you can definitely use the median values even for ordinal because there is a magnitude and ranking possible on such kind of a data. Agree? Okay, now move to the third one, mode. Guys, what do you mean by mode? When can you call something as a mode? You able to remember anything?
I think it's most number of occurrence.
Yes, right. Even in the yesterday session where we are trying to talk about parent-teacher meeting, we talked about the mode, right? The most frequently happening element or item in a set is generally referred as the mode, right? So the most frequently happening element is generally called as a mode. Let's try to select what kind of an details that we will have. So I'm just trying to talk about the same data points, right? So whatever the data point that I have taken earlier as per the median case, I'm just trying to make use of it. And if I have to call about the mode, guys, what is the mode? Which particular numbers are getting repeated here frequently, more than one?
55 and 56.
Oh, there are two? Are you sure?
Yeah.
Yes. So it means here in this particular set of 11 elements, there are two elements which are getting repeated twice. So the reason we call it as an bimode. Okay, because there are two elements which are getting most frequently repeated. So the reason we generally label them, we give such kind of an examples as bimode. Okay. Now for the same example, what I'm trying to do, I'm just trying to remove one of the 55 value because 55 is getting repeated twice. On the same data set, I'm just trying to remove one number. Now what would be my mode?
56.
Only 56. Now you call it as unimode. It means depending upon how many elements are getting repeated, right? We call them as bimode, trimode, pentamode, hexamode, and etc. Okay, just a name. It does not tell you anything. It's just trying to tell you, okay, these are the total number of elements that are getting repeated in this particular set. What I'm trying to do now, I'm just trying to remove another number of 56. Guys, let me pick a person. Shashank, what is the mode of it?
There is no repeating number, so I think there is no mode.
Excellent, right? Don't say that it is like a pentamode or a decamode. Okay, so guys, if a number to be called or to be eligible to be called as a mode, it has to be repeated at least twice, right? But here, each one of those numbers are unique. Is there any repetition on the numbers, guys? Is there any repetition?
No.
No. So the reason we call it as a no mode. Okay. So what is your takeaway here? Are you able to make any inferences out of these examples or the concept?
It is also not sensitive towards extreme values.
Very good. It is also not sensitive towards your extreme values because getting a repetition on the extreme value is very, very rare. Okay, because the moment we say anomaly, it is like a one of a case. Now you cannot expect a anomaly to be getting repeated many times, right? So this is when we say even your mode is not sensitive towards your outliers or extreme values, right? And at least with respect to relative to mean, yes, it is not at all sensitive to outliers or extreme values because the mean is the one which is getting impacted because you're going to make use of each and every value present in the set. So the reason the moment you have an outlier, your mean will get impacted very hugely. Okay, so the reason we can say that even your mode is not sensitive towards your outliers. And next thing, the data has to be, think a little, just don't answer fast. What should be the data?
It can be both numeric and categoric.
Very good. The data can be numerical or the data can be categorical too. Okay, are you clear about this, guys? It means the mode is a central tendency value which can be used for your numerical data, and if you ask me, it could be one of the best central tendency value for categorical data, right? Because the moment you're trying to talk about numerical values, here we are lucky that we don't get any decimal or floating point numbers. So the moment you're dealing the data with respect to floating point numbers, to getting a repetition to that kind of an decimal point value is very rare, right? But when you talk about categorical data, so definitely you could see a lot of repetitions in a particular scenario. So the reason you can claim your mode central tendency value can be one of the best measures for when you're dealing with the categorical data. Okay.